Welcome everybody to ANIMATHS. In today's video, we shall be doing linear equations. Okay, so we'll be doing linear equations in one variable. This chapter is taught in 6th standard, it is taught in 7th, and then it is taught in 8th too. Okay, so I have found that this chapter seems to be very difficult to my students, so I thought I will make a video on this. And this is the very beginning of linear equations. So if you are seeing other videos which I am going to upload very soon, other videos on linear equations, please don't forget to see this particular video, because this will take linear equations from a very basic level. Okay, so in today's video we shall be talking about what linear equation is, what linear equations, how do we make linear equations from a statement, okay, or from an equation how do we convert it to a statement. We shall also be doing few will be doing verification. Okay, we shall be doing some verification of linear equations. You will see what exactly I am talking about. Okay, so let us start with the topic. As I said, there will be many videos on linear equations. Please go serially in this particular chapter. Okay, as I said, the difficulty level will keep on increasing. Okay, so let's see.
Let us now see what are linear equations and which equations are called linear equations. How shall we recognize a linear equation? Okay, so let us see. Linear equations are those equations, you see, I'll write one here, 2x plus 7 is equal to 15. Now this is a linear equation. We are going to learn to solve this type of equations in this chapter. Now why do we call it a linear equation? Whenever we see that in an equation, this is the unknown variable over here, okay, the unknown variable has a power 1. The unknown variable can be in many places. It can be here, it can be there also. I can have a 3x, no problem. Okay, but then this unknown variable has a power 1. Then it is called a linear equation. Okay, that means here nothing will be written. That nothing is written means power is 1. If supposing this one is here, a 2 is written. Even in one of them, there is another place where we have a x, but still in one of the x's there is a power 2. Then this equation is no longer a linear equation, it becomes a quadratic equation. You can even have a power 3 here or a power 4. Those will be categorized as different types of equations. So linear equations are the ones which will have a power 1 for the unknown variable. Okay. One more thing, why do we call it linear equations in one variable? Why one variable? Because the only unknown here is that of x. Okay, that is clearly only one unknown variable is here. There will be more equations later on which will come up in your higher classes where there will be two unknowns, like we can have a y here. Okay, then it becomes linear equations in two variables. But as of now, in this class, we are going to do only linear equations in one variable, that is only one unknown will be there. And we'll have to find the value of x that satisfies this particular equation. In other words, that value of x, if we put it here, okay, then it will satisfy, and we'll also put it here. Supposing we put a 2 here, we have to put a 2 here also. Both the sides will have equal value. That is the meaning of satisfying an equation. So linear equations in one variable, you know how to recognize it now. That is, we have to check for the power of x. If the power of x is 1, it is, and everywhere, all over the equation, power of x is 1, then it is a linear equation. Okay, and we'll also have to see how many unknowns are there. If there's just one unknown, then it is a linear equation in one variable. Okay, now let us come to the sums. The very next, the first type of sums that we will do is we'll convert a statement to a reason. We'll convert a statement to a, sorry, not a reason. We'll convert a statement to an equation, to a linear equation. Okay, 5 times a number, 5 times a number equals 40. 5 times a number equals 40. Now this is one statement. How do we convert it to an equation? Whenever you see a number, a number means it's an unknown. We have to represent it with an x. 5 times means 5 into x. Okay? Equals, put the equal to sign for the equals, 40. Now this is our equation. So from the statement we got the equation, as simple as that. Now we don't have to solve it at the moment. We are not learning to solve it. Okay, today we will only learn to form an equation from a statement. Let me take another one. 5 subtracted from thrice a number is 16. 5 subtracted from thrice a number is 16. Now this is another statement that has been given to us. The moment you see a number, this has to be represented with the unknown variable x. So 5 subtracted from thrice a number. Now remember one thing, whenever the word subtraction comes, we have to look for the word from, and the number or the variable or the term before which from comes goes in front. So thrice a number goes in front. Okay, and 5 has been subtracted from that, 5 goes later, is equal to 16. That is, before which from comes will always be written in front. Now this applies to if this is a decimal, even then you write it in front. If this is a fraction, you write it in front. It's an algebraic expression, even then it applies. It's a term, it's a negative term, even then you don't have to see what it is. If you see the word from here, you write it in front. Okay, it also applies for if the one before which from is written is actually smaller than the other one. I mean to say this is smaller than this, even then you have to write this in front. Okay, whichever has the word from here goes in front, from before it goes in front. Okay, so here we got the statement 5 has been subtracted from 3 times a number and then it equals 16. Is 16, here we use the word equals for is, and is 16. Okay, then the next one. We'll take another one with a subtraction. Twice a number subtracted from 19. Subtracted from 19 is 11. Okay, twice a number subtracted from 19 is 11. Then, so twice a number, that means it's a 2x, and here the word from has come before 19. So 19 minus 2x is 11. Is the equal to over here. Okay, so twice a number subtracted from 19 is 11. Then next is a slightly different one. Just check. 25 exceeds a number by 7. 25 exceeds a number by 7. Now there's a lot of confusion about this word exceeds. Exceeds means 25 is more. So 25 exceeds a number by 7 means it is already more than the number. So we have to subtract the number. The number obviously is x. So 25 exceeds means 25 is more. So write it in front. Exceeds a number x by 7. Okay, so 25 exceeds a number by 7. This is our equation. Another simple one. A number divided by 8 gives 7. Now you will see that the equal to is written in different ways. Okay, sometimes it's written in different ways. Equal to sometimes gives, sometimes is, sometimes you'll find equals. Okay, a number straight away, a number is an x divided by 8. Put the 8 here, you don't have to put the division sign and 8. Put the 8 straight down, you get the equation in one step. Gives us an equal to, and put the 7. Okay, a number divided by 8 gives 7. Now what to do next? Next we'll be doing just the reverse of this, that is, we shall be converting an equation to a statement. Okay, now we are going from equation to a statement. This is our equation that has been given to us. This is our equation. Now we'll be converting it to a statement. Okay, so we are not going into solving this. As I said, as of now we are only doing equation to statement, statement to equation. So this is the next type of sums, that is equation to statement. How do we convert it? So for this equation to statement, we'll have to first, this is our a number. We can write it as a number you can write it as 7 subtracted from a number, okay, is 14. As simple as that. Okay, so here is our unknown, 7 subtracted from a number, this is x, and see, from I have used, so I have used it in front. 7 has been subtracted from it, is, this is the equal to, is 14. We'll take more examples. Next is 12y minus 30 is equal to 6. Okay, this is the equation that has been given to us. We will try and convert it to a statement, that is in words. "30 subtracted from 12 times a number equals 6. Okay, 30 subtracted from 12 times a number equals 6. This is our statement. Let's take another one. Next one is 2z by 3 is equal to 8. Z. So here is the variable z, by 3 is equal to 8. Okay, so what do we do here? This is, now you don't understand how to write it. The quotient of twice a number and 3 is 8. This is the quotient of twice a number and 3 is 8. This is our statement. Okay. So what is the meaning of the word quotient? It means nothing but the answer of a division. So the quotient of twice a number and 3, please don't write the quotient of 3 and twice a number. If you say that, 3 will be taken on top, which is again wrong. So quotient of twice a number, then comes 3 is 8. Okay. Now we shall be doing the third type of question, that is verification of linear equations. Now what do you understand by verification? Verification is we'll have to check whether it holds true or not. Now let's see what holds true. Verify, the question comes like this: 3x minus 5 is equal to 7 is 4. Okay, is, sorry, I'll write a full thing, the root of 3x minus 5 is equal to 7 is x is equal to 4. Means they are saying the root of this equation is 4. Now this is a new word for you. What is root? Okay, what is the word root? Root means nothing but a solution of this equation. In other words, an answer of this equation. That is, if we solve this, x value will come to 4. To explain it in a different way, root means that value of x which we substitute here, then it will solve this equation. Okay, so if we substitute x is equal to 4 and then solve this much part, we should be getting a 7. Then the value x is equal to 4 is a correct value, is a correct root. So now we are going to start with it. LHS. We always start a verification with an LHS. 3x minus 5, that is 3 into 4 minus 5, that is 12 minus 5, that is 7. Okay. So 3x minus 5 is equal to 7. So we can already see that this is equal to the RHS. Okay, so we have substituted 4 in place of 3x and we are getting a 7. We can write below this, hence verified. That means hence we have proved. Okay, so this is the meaning of verification. That is, we substitute it and we show that it is truly satisfying the equation. Let's take few more examples of verification. There can be some with a slight difference. This is, let's take the root of 5x minus 8 equals 2x minus 2 is x is equal to 2. Okay. Is x is equal to 2. Then what do we do? Here we shall be solving it again, but then left hand side 5x minus 8. Okay, that is, we'll substitute the 2 here. 5 into 2 minus 8, that is 10 minus 8, that's a 2. This is the left hand side. Let's go to the RHS. 2x minus 2, 2 into 2 minus 2, that is 4 minus 2, that is a 2. Now what do we see? We can see clearly that both sides is coming to a 2. Therefore, we can say that the LHS is equal to RHS, hence verified. Now, I've seen many students doing it in a slightly different way, which is not correct. It is not the correct practice to work like that, what they do is, the moment they see this 2, they'll be substituting the 2 here and the 2 here, and they go down like this with the equal to written in between, and they go down with the calculations. End of it, they reach a 2 here and a 2 here, and the final sentence is 2 is equal to 2. That is a wrong practice, because if they are asking you to show, yes, this side is equal to this side, that is what they are asking you, for the value x is equal to 2, is this side equal to this side, then you can't tell them that, from the beginning only, if you are writing the equal to sign and going down the calculation, then it is a wrong method, because right at the beginning you are telling them, yes, they are equal, then what is there to prove? Okay, so there's a very common mistake, very common mistake, 60 to 70% of the children actually do this. They substitute the x here and they'll go down with the equal to written here. So verification should always be done the LHS and the RHS way, and no other method. Okay, now let us come to another example of this quickly. The root of, so all these they are asking to verify the root of, okay, I'll write verify if you are confused. Verify the root of z by 7 is equal to 8. Z is equal to 56. Okay, so LHS, left hand side, 56 by 7, that is an 8, which is equal to RHS. Okay, see, I started from the LHS, okay, then my calculation reached the RHS. I didn't copy this. Okay, my calculation reached the RHS, that is equal to RHS, hence proved or hence verified. Okay, so we can say yes, Z is a root of this particular equation. That is, if we put the value of Z here, it will satisfy this equation. Okay. So what are the things we did today? We did converting a statement to an equation to a statement, and also verification of roots of linear equations. Okay. We also understood what is a linear equation and how do we recognize a linear equation. Okay, that's in the very first part of the video. So we shall be doing more in this chapter in my next video. So you see to it that you are watching these videos. As I have told, you should watch them serially, as they'll be numbered. So these videos will be numbered serially, and please go serially in these videos to get a very clear concept about this chapter. Okay, so thank you so much for watching this video, and if you have liked the video, do not forget to like, share and subscribe. Thanks all of you.